Now we move on to the rational zero theorem, which seems to be rather complicated when you read it, and I'll have you read it on your own. But I want to focus in on this paragraph here. The rational theorem does not guarantee the existence of zeros. It says if there's a rational zero for a polynomial, then it's going to be on this list that we create. Basically, here's the procedure. Look at your polynomial and find the factors of the leading coefficient and the trailing constant. The factors of 25 are 1, 5, and 25. The factors of 10 are 1, 2, 5, and 10. Okay, now what we need to do is we need to put the factors of the ones at the right over the factors of the one at the left. In other words, we're going to have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, all divided by plus or minus 1, plus or minus 5, or plus or minus 25. When we simplify all these fractions, we get plus or minus, and I'm going to write this as one big set so I don't have to write that plus or minus over and over and over again. Each of these factors in the numerator over 1, which gives us 1, 2, 5, and 10. Then each of these over 5, 1/5, 2/5. Now 5/5 and 10/5 are the same as 1 and 2, so I'll skip over them. Then we put each of these over 25, which gives me 1/25 and 2/25. And 5/25 is the same as 1/5, and 10/25 is the same as 2/5. And so we have this list here, and you see that I've written out 8 terms. There's actually 16 here because of that plus or minus. And this theorem basically says if there's a rational zero or a nice zero for this polynomial, it's right here on this list. It gives us great power because we don't have an infinite number of choices. It's been narrowed down to these 16 values. Does not guarantee that any of these do in fact work, but it gives us a nice finite number of things to check.